Welcome back. In the second video of this series, we're going to take a look at Cisco SDA Fabric. Cisco SD-ACCESS is the Cisco's digital network evolution. It's transforming the traditional campus LAN design to intent-driven network and programmable networks. So really the two main components of Cisco SD-ACCESS are Cisco Campus Fabric and Cisco DNA Center. So Cisco DNA Center offers essentially automation and assurance to create and monitor the Cisco Campus Fabric. Uh, in terms of roles, Cisco SD-ACCESS, there are different. It's different from the traditional roles in the three-tier architecture, where Cisco SD-ACCESS is built on a fabric technology implemented for Cisco networks by using underlay and overlay networks. Overlay is running on a physical network underlay to create a logical topology. The underlay network is a traditional physical network connecting LAN devices such as routers and switches in the network. An underlay network's main purpose is to provide IP connectivity, really, to enable traffic to traverse from a source to destination. So basically, because underlay is an IP-based transport mechanism for the traffic, and an IGP can be leveraged, and Cisco is using ISIS for that purpose. Fabric roles and terminologies in SD-ACCESS are different in many ways. So we look at the edge nodes and at the bottom in yellow colors, and in the middle of the fabric the legacy the devices can be legacy IP devices as long as they support the layer 3 connectivity. And then we have the border and control node. So borders essentially act as a border of the fabric connecting to the rest of the IP network, and the control plane nodes essentially based on the Lisp register servers to keep up all the record of all the control plane in the fabric. So essentially these are the overview at a high level makes the Cisco SD fabric. So we've got, then on top of that, we have the what we call the concept of a fusion device. And fusion is essentially a device which sits outside the fabric, and it connects to the rest of the IP network of the enterprise. That is a sort of a gateway and a proxy between the IP network and rest of the enterprise network. So the other construct of the SD fabric is what we call the IP area, which is where all the components, the controllers of the SD-ACCESS sit. For example, DNA Center and Cisco ICE, and WLC. So this zone, which is a reachable to the fabric via the IP connectivity, is typically outside the fabric, and this is where the DHCP, DNAC, and ICE elements will live. So some of the other components of the fabric, just to recap, is we have inside the fabric we have edge nodes and control nodes and border nodes. So as I said earlier, the edges where all the endpoints connects, the controls are keeping the control plane via the Lisp. We're going to take a look at that in our coming videos in details about Lisp and VXLAN. So the edge nodes are typically giving access to all the wireless and wired clients, and that's where we're going to use the mobility element of Cisco DNA Center to give that access to all the endpoints in the SDA fabric. Just to recap the Cisco SDA fundamentals, Cisco SD-ACCESS is based on two key components: the underlay, which is where Cisco is running the layer 3 links and using IGP as ISIS as an IGP to provide connectivity, and the overlay network. The fabric is essentially an overlay network. Overlay networks are commonly used in the IT world to virtually connect devices such as Internet Security Protocol, GRE, and DMVPN. Based on those trends, Cisco has used in the overlay as a control plane protocol Lisp, that is Cisco's proprietary, and VXLAN, that is open source, and in the data plane. So essentially, VXLAN in the data plane is slightly modified. It's a VXLAN GPO, that is a RFC draft.